Welcome back, guys. So let me just. Okay. Today I should be able to also respond if there's any comments. I was trying out this, but yeah, let's see. Anyway, I hope you all doing well. So, last week we were using some helpers and maybe writing a high level helper that will be actually using the page allocator and do some stuff. Maybe you could just go through it and see what we can do today. Yes, yeah, we wrote the Kmalloc that's just going to allocate pages and map the entries. And yeah, I think we did not write the map entry. I guess it's just dummy. No, we did write it. Okay, we have wrote the map entry too. Okay, that's good then. So I guess we have everything. Maybe today let's just try to run it and see how good it is, and then maybe fix stuff there, and then we should be finally be able to write the actual syscall, because the whole thing about this was to write a syscall that can allow userland programs to allocate memory, because right now still there's nothing running on the userland. Actually, there's no syscalls at all in my kernel. Right now there's only kernel. Yeah, so to start right, I mean, I guess I have already written the userland program once. It's just that in that example I didn't have any syscalls to make. Now if I can make this MMU work plus write a mm, helper, then I should be able to call that from userland, and then it goes through the syscall and comes here and it calls some helper and it does all that shit. So yeah, let's just keep checking. mm, I guess this is how we tried to see if the allocate memory is working. We don't care about that anymore. We can release that. Now we have a high level helper that can do everything for us, and it's going to give us a void pointer test, and we could call Kmalloc. And before that we should maybe probably write it down somewhere. Okay, it's control, and we could just say extend void star. Maybe this was the helper that's supposed to give that. Okay, maybe we change it to Kmalloc. We have changed it to Kmalloc, and it's going to take an event 64 size value. Okay, and we are good to go. If we could come down and if we go back to our Example, let's say we want 300 bytes. I don't know why we want 300 bytes, but let's just say we want 300 bytes. And maybe we could write something into it. We can say like we could just say it's char pointer. Mm, 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 char pointer name equal to, we could, I don't know if this is correct, so let's just try. There's no harm in trying. If I take 0th character and just put, what can I put there? Can I just type, this is static, right? Then I don't know if it will even work. You are printf and let's just it takes a const character star, but we have normal character, we don't have a const. Can we assign this as const? What does const mean? I guess we can change the value inside it only if we put char const, then I guess you can't change the pointer and you can't change the value inside it. I think if we remove this, yeah, still I guess right now I shouldn't be able to change the value inside it. This statement should fail. Well, let's try and see what's there. Then we can think about what to do. But the whole point is that we should have allocated some memory, and we should have gotten the page table entries for that new memory, and we should be able to write to that, and MMU should be able to see the table entries, and everything should work normally. Let's try. Let's see. Let's build it. We have our builder and we have thousands of errors if we can get through them. And what the fuck? We have an error at start.s. Did I even modify start.s? I don't remember modifying it. Did I? Oh, I have modified it. I can see some green lines here. What did I do? We are writing x13 what? I mean, and yeah, we are storing it in top of the stack to pass that value to kmain as the first argument, because x0 will have the first argument. Because this was working for a long time. How the fuck did it stop working? Did I change something after that? I don't recall changing anything. I believe it was working just freaking fine. Maybe these 3 lines. What is this? That's just fucking empty lines. Okay. Now let's assume that that's our end last thing to be worrying about. Let's just fix the things that we recently put into. Where the fuck is allocator mem? My link is bashing at me. It's like, where the fuck is that thing, you piece of junk? Did I call it somewhere? It's allocated below and it's called above. That's the issue. Maybe we could just select this, click delete, and come here somewhere. Okay, maybe here, and paste it. I guess hopefully it won't complain anymore. It shouldn't. No, that's still complaining. What the fuck? Now it's line 247. 247. The fuck? Dude. Maybe I'm looking at old logs. Ah, okay. It's good. Now I just have to move set bitmap to the top, or I just declare all the signatures in the top so I don't have to do the other stuff. Maybe that's the better way to do it. Let's just recall everything. We brought it back down. And let's just see if we get the old error, and let's add the function signatures on the top. And that should be good. If we yank it and if we go to the fucking top and paste it here and just add a semicolon. That's good. We have one signature. Now we need to add the signature for this. Let's just yank it and go to the top, paste it here back, and press whatever, and press the thing. And I guess finally we have to do this one. Yank it. I'm getting a fucking call. And I could just paste it here and press the semicolon, and we are good to go. We have just dealt with this fucking error. Now we have one less thing to worry about. So we have printf. I don't know where the fuck printf. Why did I call printf within YAML? Do I even have printf? I don't think I have printf. How do we call something that we don't have. Who the fuck do we think we are? Ah, holy moly. Oh. Oh. What? What the hell is this? It is randomly called printf. Was I even in the right state of mind to write that fucking line of code? I didn't even import UART. Holy shit. I just remembered. We just copied it from somewhere. Yeah, we wrote it externally, we built it, we tried it out, and then we just copied it back here. Oh, okay. I remember it. I'm not that fucking dumb. Hopefully. Let's just fucking remove this. We don't need it. It's just for debugging purposes. Maybe it will come in handy, but rather not at this point. It's not the trouble that we have to deal with today. It's some others. Now we have only one error. That's this fucking operand. But it was fucking working for a long time. How the fuck it all of a sudden decided that I'm not gonna work? You fucking one. Okay, let's think about it. How we can fix that. What am I doing here is that it's just that I didn't want to allocate page table entries for what's that? The address range that starts at 4000, I guess, for 4000, because QUMU, the emulation tool that I use, is dropping the entire DTD in that address. It's a hard coded address. So if I have to, I mean, I have a helper that can pass it and take the total physical RAM, but then if I have to pass it, I have to have page table entries if I have to call it from kmain, and I was too lazy to add those kmain entries. So what I did was I called it even before enabling MMU, because I'm enabling MMU here, but so I'm calling to get total RAM here. But the second issue is it's all fine. Now I don't have any MMU issues, so I can call it and it works fine. And I have the output. But the thing is, now I have to move the freaking value to the kmain. So how do I do it? Probably I have to store it somewhere and take it. Where do I fucking store it? I don't know, because I didn't have any place to store it. So I was just checking around, and this X13 register wasn't modified by these fucking freaking instructions. So I just stored it there, and I am assuming that it will be there when I reach this particular line. And when I tested it, it was there and it worked freaking fine. Now what's the issue? Now what I'm trying to do is that I'm trying to take 16 read from top of the stack and copy it into x0 and x1. I guess this is a quirk because I only need x0, but for some reason this freaking ARM architecture only allows me to read from 2 registers at a time. I don't know, something like that. Wait, now I have a question. I'm moving x0, that's the output of get total RAM, into this register, and then Why am I expecting it to be in top of the stack? Did I miss something? Did I, if I press Control Z, what do I get? That's the highest thing I could go back. Why do I expect it to be in top of the stack? This is why I should write even more comments, because I have written a comment that please don't fucking overwrite this register. That's fine. That I understood. Even I remember that shit. But here I'm trying to read from top of the stack. I'm not reading from X13. What the hell is happening here? Oh shit. Let's fucking remove this and let's put X13 here. Hopefully it will work. I mean, that issue is gone, but I don't understand. I mean, like, that's what I've done here. I've moved it to X13 and I'm hoping that these instructions won't override that register and I could just move it back to X0. No, let's see. No, it didn't work. It did not fucking work. What was the fucking error? Let's fucking tail. What's that? QUM, what to what? Exits. Tail, QUU. I guess it's QUMU1. We have an. What's this here? I mean, we have undefined instruction. Reading this log is the hardest thing to do. Let's just fucking. What the fuck? Why the fuck is this not getting copied? Did I not yank? Oh, fuck me. Oh, what's this? Yeah, code. Is it? What's this? Yeah, code. Where's the code undefined in this instruction? CPU tried to fetch and execute instruction at 3000 and it's not valid. Why the fuck are you trying to fetch an instruction from 18 to 100? That's not your instruction range. Why the fuck? That's not your place to try. I guess. Let's break. Where can we break? Let's break at K-main. Let's see if we are even reaching that point. No, we are not. So we can rule out that possibility. Now let's just disassemble main. Disassemble in MMU unit. And this is the instruction where we. What the fuck? This is the instruction where we enable MMU. So let's just break here. Let's see if we reach that point. So we have reached MMU, and if we step once, so there's no fucking error. So there's no MMU error. So what the fuck is happening? Let's see. And we are diving into start. Wait, let's come back here. We have enabled it, and this is the final set of instructions that we are trying to execute. Was this jump? BR. Oh, this is the one where we jump into this kernel range. Okay, that's also fine. And now we are trying to do the instruction that we just modified. Let's check what the fuck is inside x13. What's inside x13? Let's see. x13. X fucking 13 has the value that we need. That is the 4 GB memory. So info registers x13, and it's correct. So what the fuck is wrong? So we have reached, we left virtual memory, so everything is correct at this point, and we have jumped into K-main. Now let's get into fucking K-main. What am I here? I'm trying to init, and this is the message I was expecting to see, but it did not. And K-main only takes one input. That's the total RAM. Let's see. Okay, some random shit is happening. Probably we are trying to print the message. Can I just continue? No, kill it. Now try to log it again. And we still fucking try to reach 8200. What the fuck is 8200? How the fuck is 8200? I think we do have 8200 somewhere here. Yes, that's the physical base address. So what's wrong with that? I have everything added. Also have this extra memory that I'm calculating. This is for something. No, this is for some random shit I was trying to do, and it's still errored out. Now I'm trying to understand how the fuck did I reach this as an instruction, because we are inside. Maybe we are just trying to read this somewhere, but if it was happening after my UART, then it would have made sense. But why is it happening before? Because at least these two statements should just fine working should work fine. What's wrong with these two statements? They're not supposed to. Hmm. Okay, we do have this address, and for that I have kernel, I mean table entries, so that shouldn't be an issue. Let's see. But I changed one thing, because here it had a different thing. This was here before. What was I expecting to write here? No freaking idea. Invalid operand for instruction move. Move from top of stack into register 64. Let's see what's the instruction. It should be LTP. If this is what I was expecting. And it did not work. And we have the same freaking error. We have ELR2. We reached this point. Well, let's just see what exactly is that. Data about it. It's literally an instruction decode failure. So it's an undefined instruction. Okay. So we somehow reached that address. Yeah, that's what I was thinking about. Why did we reach that line? Why did we reach 8,000? Because we are inside a kernel range. Why the fuck would we reach? Interesting. Disassemble K-main. Maybe it's because I have extra functions and they need to be loaded into memory, and my LLD just does not have enough memory because I'm starting here and this is my text and whatever stuff, and I also have my, what's that, 8000, which is the actual memory table value. So probably that's the issue, because maybe there isn't enough space for those extra functions to be placed, so it's getting overwritten. It's possible. Let's in that case, let's just disassemble certain things. Disassemble uart printf. Ah, that's true. No, it's not true. Maybe it's true. I don't know. Because UART is getting placed at 8100. One thing we could do is we are getting fucked up at 8200, right? Let's just copy that and we can build it and break it. Is it 1FFF? First of all, there should be an instruction at 1FFF. That's not right, so let's just say this and let's continue, and we have reached it here. Why did we reach? This was the last instruction. Probably we had some fault because we are in EL's entry sync. Well, let's go to our vector table and it's EL1 sync, EL1 sync entry. I don't have any CIG servers. I'm not handling any thing, so probably what we can do is we could just what we can do is we need to figure out why we reach this EL1 entry. Why do we reach exceptions? Then in that case, if we read tail it, where the fuck the tail command? Let's just remove Q and start a new session. Start a new session. Just continue it and break it. Now open QUMU one log. Now if I go to the end and if I come to a little bit of top, if we can move past these infinite exception, somewhere there should be the this freaking thing is So fucking annoying. Let's just go to the middle of the page. Is it control yum? I don't know. Let's just start from the beginning. Probably there isn't much instructions to even start with. We are in get total RAM. If we get past that, we still haven't get past current pasts. We are in clear table. Oh, we have reached clear table somewhere along the line. This is shit. I need to know where exactly that exception starts. And it's just... Where is it? And if I open this, and if I scroll down to... I think till this point. Just before the exception, we need to find what's the log. Then we should be able to come to a conclusion of what the fuck happened there. Okay, from here the rest of the thing is just the exception keep on happening. So this is where we need to check. This is the first exception. And it's a data apart. See? Where are we? If we can reduce the total number of QEMU logs to certain logs alone, then it would be even easier. But right now I have it like every log. Probably that's why it's too hard to check things here. See, we were executing something around here. Interesting. We are jumping into D. If we can find this instruction inside our blob or inside some of our function, we should be able to come to a fucking conclusion of what the fuck happens. But now I do at least have an idea. But it's not that we are reaching there, it's some exception is happening, and that exception handler is getting into this, and there we don't have any code. That's why sometimes we should not believe the final error message, because the final error message maybe is completely invalid. Something above that happened that led it to reach that point. I have been in that what's that, rabbit hole many times. I would be believing that the final error is the actual error message, and I would be going on about trying to fix it, and it would, because I guess it happened recently. I was trying to uh, do some shit, and it was just so fucking annoying when I finally figured that there was something just simple going on in the top. I could have just fixed it in just 1 minute, but the fucking thing, I thought it was happening some. It's just fucking annoying. Whatever. But this is the first error. I think this is what we need to care about. Oh, what the fuck? Sometimes my yank does not work. I don't know why. Why the fuck is my yank not working? Did I not yank it properly? What? Bro, 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 bro. Leave it. I'm. Oh, my fucking VS Code is stuck. Oh, that's why it's not yanking. I guess because it's just too huge file. VS Code is not able to handle it. Well, at least we know the line number, so we could just use Vim. It's just 301771. 301771. If we go to this line, and if we could just copy this fucking freaking line. Yank it. What? What? Did I not change? Okay. I have not enabled that feature for my normal Vim. I can't simply expect to yank inside VI and hope that it will be copied into my host clipboard. That's just shit. That's just shit. That's just shit. How to open line number? Read from line number with cat. Okay, this will print the line number, and then I could just use it. Or I could tail with this. I guess I'll tail with this. No, it would still be fucking so annoying. I can just use SCD, I guess. SCD is better. And 31 something. What is that line number? This is still stuck. If I escape it, it's not going to normal mode. I guess it's fucking stuck. I'll go to line number 301759. 301759 230 1768 301 Oh, finally. Fucking finally. Do we have X clip? Cell clip. I don't know how fucking X clip this. I hate this macOS. Fucking Linux was so much easier. 905, so it's exception class data about. It's a level 1 false. See, this is the actual issue, it's not something else. We have a level 1 access false. And we are trying to read which memory? Okay, I know that 905 means access fault and it's level 1. Okay, I have to remember that next time. But now what's the actual address that we tried to read? This was the address that we tried to read. And why did we get an access fault for this address? Wait, that looks familiar. Because if we stop and disassemble MMU init and we have faulted D94. I guess it's X. Instruction is I. And if we just take this part, yeah, 0x. MMU unit 596. It's D fucking 94. Why the fuck did it paste? Oh my fucking god. It's killing me. D94. Check free. We are inside check free, and that's when we tried to try something out. But what the fuck? Check free? What do you mean check free? Where do we call this bullshit? Oh shit show. We call it inside find free. Where do we call find free? We call it in set bitmap. Where do we call set bitmap? We call it inside allocate mem. And where do we call allocate mem? We call it inside kmalloc. And where do we call kmalloc? We call that fucking thing inside kmain. But it's here. Why my fucking this did not get printed? Oh my fucking god. It's killing me. It's fucking killing me. Init location. Why did we reach that line? Let's just comment everything out and let's run. Where's my fucking let's just bash and continue. let's go to tail. Now we didn't get any error at all. We were just doing this thing. So something else changed. What the fuck changed? Why is my printf not working? It was working till this fucking day. And you decided that you are not gonna be interested in fancying me anymore? That's not good. That's not good. That is not good. Let's just review our git log. We have added one fucking thing and we have called it. And maybe this fucking line still seems fishy. We have to think about that. But even if that fails, it just has to fail in the total RAM. So that does not have anything to do with printf not being able to print anything. Mm. La 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 la. Ooh. We have changed things. What is this change? We have changed L2 address to 6000. Okay, that's not bad because we have 4 KB pages, so 100 is 1000 is enough. That shouldn't be an issue. And we have added this extra page table entry that is just calculate the page table entry. Okay, we have added that to do. And this rest of this stuff should not fuck with my printf. What did my printf do? Oh, we have added something. What the fuck did we add? Looks like GPT generated fucking thing. Okay, we added support for long. You okay? I know that. And we have added some extra space into linker scripts. Oh, this is for top of the stack. This entry. This is for the top of the stack. And that's why it's failing. because I'm mapping my top of the stack. I mean, no, that's was that no, because this is A00. This is just A0. I remember it because I used it here to try some random shit that was just not working, so it should not matter. Wait, wait. Maybe because I'm doing this shit, it fucked up my base table entries. Let's see. Nope, nope. It did not matter. Holy moly. First of all, there's no error. That's the biggest issue right now. At least if there's a fucking error, we could do something about it. Now we have to completely review all our code and see what the fuck did we do and think about something. Shit, show. What is this? Maybe it's the file. God. Now we have to figure out this. There's no other way. We have to figure out this. I mean, it shouldn't be hard. I just have to understand what are the changes I have made and see which change fucked it up. That's it. Nothing much. But instead of trying to figure out every fucking change, I'm trying to be a little more precise about all the changes I have made. Right, let's just add what's this thing? It's QEMU VI. I guess it's git ignore. There's no fucking git ignore. We have git ignore. And let's add QUMU. And now if I put git dev, I should not get anything other than okay, let's see. We should be able to see something this time. Out of this change, something fucks up my UART. Probably the code, the long integer code. Maybe I'll have to review the change and see. This is the change that I might have to review to come to a conclusion of what the fuck is happening there. Why is my QEMU not still done? Oh shit. Wait, status. What else have we changed? I think we didn't change after anything after that. This is it's just all files. So only something between these 3-4 files that we have to somehow find what is that. And at least UART is running, so it's not that hard to figure out it. We could just start by adding this line. Where's that line? This fucking line. Copy that fucking line and let's just put it here. Let's see if UART works at all. That should be the fastest way. So UART is working. So it's definitely something wrong with my fucking code. I just changed something and it fucked up. What the fuck did I change? What the fuck did I change? Dude, I did not even touch that fucking code. Dude, when did I fucking touch this code? I don't know. So let's just keep on putting this somewhere. The good old printfs. What am I trying to print? I'm trying to print kernel starting. So it has to switch in this line. No, there's no modifiers here. It simply has to print because there's no modifier. So if this is the current value, then it should just say here. Let's see if we are reaching here. How many times do we reach there? We don't reach that state. See, that's the issue. Something fucked up. Okay, I have to close this file. My fucking VS Code is not able to handle that file. Okay. There is no we are printing this line. Let's just also confirm that we can print this line. And then we have this thing where we come here and we print this line. Shit. I should be doing stuff, but okay, so we are reaching this line, but we don't reach this line. Why? Who knows why? Why is I not less than full? Maybe that just means there's nothing in this fucking full. What is struln? Maybe why not just fucking put strln? Do we care about fucking safety? Why the fuck did it error out with the strln? What is struln? Maybe I wrote that code. Okay, yeah, I don't have libc, right? I'm so fucking... Yeah, I don't have libc, so I must have wrote that helper. It's here. What does it do? It simply takes It takes the character as character pointer and it just keeps incrementing it. Now our job is to get inside this and create a segfault. Something increased, so I don't know, maybe I have to change this text to something like 7 because I don't know if I'm reaching that point or not. So we have reached it and we have only reached it once. Why? Yeah, we are calling it once, so it should reach there once. My fucking god. I have to see. I have to see. What is I is 0. What is full? Full comes from here. Why is I less than full? That's not supposed to be. Oh, we have this. Let's see if that works. No, that didn't work. I don't know why it didn't work. What's your puts? It's just going to keep seeing that as long as this is a pointer and it will someday fuck me up, but it's fine. It should not fuck me up today, so it's fine. It's fine. I is less than full. I is fucking less than full. I don't fucking understand. This is a string. You should have gotten it. You're fucking with me, my fucking. What is it? No, it is not funny. It's not funny. It is not funny. Oh God, it's you art, and I have this value, and it's not funny. It's not funny. It's not funny. I have standard dogs. There's no issue with you art. Something is wrong with my fucking code. Because I'm just fucking passing a string here. What's wrong with that? Let's try something else. Let's try a single character. What the fuck is wrong? Nope, it did not print that. but it's getting into that function. Maybe the input is not getting passed. Maybe we could see it in our fucking debugger. That's the best way. Disassemble. Oh, we could just print UART. B star UART. B UART. Printf. And I send. Holy fucking moly. It's not getting printed. Let's just put disassemble UART. Printf. And I come to the top of my printf and I become Japanese. This is just fucking annoying. Let's just copy this shit. Now if I continue, why the fuck it didn't print there? Stop there. Holy fucking mo. I just remembered. I have to put stars because I'm in a fucking jail. I have to put stars in front of it. How do I put that? We just go to the last 1 2 3 4 1 2 3 4. Now it should work. Yep, it worked. Now we are inside a printf. Now we have to check the argument, that is x0. X0 is some random shits. X0 is actually 0. That's the fucking reason it's not working. How the fuck it's supposed to work if the value is just, we are calling something here. In that sense, the first argument should be inf registers x0. What the fuck is 6b? 6b? What's the first function I call inside UART printf? Shit, I have my fucking helpers that are fucking with my state of mind at this point. Let's just fucking remove them. Sometimes I just introduce my own fucking error and I deal with it for 5 hours to figure out that it was my fucking error. Oh fuck me. Oh shit show. And I'll disassemble printf. It's UART printf. And I'll go to the top and I'll go to this fucking line. And I'll update the first 5 characters. Now if I print this, I'm inside that. Now let me do what? What should I do? All I have to do is print info registers x0, and we have it here. This is, holy fucking moly. and it's just 0. I think this is the stack. Where's my stack actually? Wait. Or did I just quit? Oh, fuck me. Shit. Now I just have to inf register. And I have to put SP. And stack is pointing to... Is this the stack address or stack is pointing to this? This is stack address, I guess. Let's just... Oh. Stack is using... Stack is still pointing to... pointing to the physical address. But I do have page table entries for it, so it shouldn't be an issue. Let's see. Yeah, so it is possible to read them because I do have table entries. Let's just read 10 entries out of it. 20 entries. Stack does not have anything, literally. That's not good. What does this prologue mean? We move SP to SP20? What does that mean? Subtract SP from SP20. No idea. No fucking clue. I know it's fucking prologue. It's supposed to set up the stack. I mean, set up the stack frames. Wait. And I have my fucking helper here. I'm gonna fucking kill my helpers. Why are there jumps? There's one jump here, and why is there another jump? Oh, it's just jumping here. It's while loop. Fine. It is just jumping to this line. 54C? It's jumping to 54C. Okay, it's jumping to this line. Okay, that's fine. Man, at this point I have no fucking clue. Only thing that, let's just recap what are the information I have for this debugging session. I know for sure that I am here and I am calling this UR_printf, and there's no fucking reason to believe that UART is failing because I can just print something and it's there. But I do have reason to believe that this fucking parameter is not getting passed from here to there. Maybe it's possible because of my stack, because my fucking stack is still pointing to this. Maybe I should just set stack pointer to that value. So it should, but still I have page table entries for this memory address too. So it shouldn't be an issue. It's just a random address. And I don't have any overlapping, right? Let's see. Yeah, my stack top is this. Stack rows downwards. Heap rows upwards. I guess so. What the fucking shit show? It's a fucking shit show. It starts around 8. This is the extra thing that we have added recently. And all of a sudden, things just started to happen. Hmm. Hmm. Wait a minute. We're calling you art in it. And what the fuck is this? Something's definitely getting overwritten. Because why does it say EL sync entry here? And it only happened after we added all that shit. Let's see. Let's try to remove all that shit. fix our k-main. Now let's try. See, it's working. I knew it. I fucking knew it. So we are overwriting something, so we just need enough space. I think because those functions should be written somewhere, but those actual values are getting overridden. Let's see where. Not we disassemble k-main. We should be using vector table here. Maybe, just maybe. So there's nothing wrong with my UART code. Everything has to do with this BSS. Wait, where will all my functions code will be put into inside text or BSS? I guess BSS is for global variables. I think it will be inside text session. Okay, so in that case, I just have to increase this increase the size of text block in what's that linker script. I think I just have to put dot. Oh, we need to increase the memory region. We can do this padding. I think I'm gonna try this first of all to see if at all it's the issue or maybe something else. Who knows? Who knows? Let's just try. Let's just put another 6,000 here. And see what is the error that we get now. let's just mm, uncomment these things. Maybe it's completely something else, but this is all I have in my mind. So, because I could see that something is overwriting that 2000 range. Something. I don't know if this is the one. But we'll try from here. Now it worked. Maybe because I didn't link it in the K-main. Let's just link it here. It fucking works. So is that the true issue? Because I didn't change anything else. Well, let's see. Let's remove this line. And let's try. It fails. And if I add that line, and if I try it, it's working. Fuck me. Fuck me. Shit. Okay, now I know what's happening. Now I have to understand why this is happening. Because I still have no fucking clue. Let me fucking ask the search engine that we have. If I add the extra padding in the text section, my code is working. Or if I remove the extra functions I have newly added, then the code is it that the new functions are overflowing the text region? What is the root fucking cause? Oh, no, root cause. Okay. So what's the fucking root cause? Okay. First of all, give me the fucking root cause, you piece of shit. So I just got lucky. That I know, because I was freaking sure that that's not a. I just knew that's happening because the pointers were changing. Oh, I have to add an align statement after that. Okay. So this should solve it. So the actual thing is that I need to properly state these things in the linker script because I still have no idea of how to write a proper linker script. Oh, fuck me, bro. Fuck me. Let's see if it works. It works. That's fucking interesting. So what was the issue? Let's check that. My code grows into RO data. Okay, I get that point. So if we add the align statement after every block, no matter how big the code grows, the next block will only start after this alignment. Yes, the start of the next block is moved up to the alignment boundary. Big the previous block grows. Does not limit the. It simply guarantees that the next block begins at a safe aligned boundary. Not that it starts far away. Okay, so if we overflow the memory region, then still it would be an issue. Okay. But I think that I have maintained it because I'm starting off at 8,000 and my stack is one. It's like at least there's enough space. I think it should be fine. Now there's a possibility that BSS might someday overwrite my start block. No, I have a line here, so it should not. No, it can. Because this is not static. Is BSS static? It's global variable, so maybe it's static. But if I have a global variable overflow, oh, that's not possible because global variable should have some sort of static memory. Okay. But yeah, maybe I could just write a note saying that think about memory region overflows as we might overflow in future if we grow past the initial kernel block. This happened in the text region as we added more functions to it. Okay. I think it was a good lesson to learn that whenever your functions grow, you also have to make sure that things around it is not getting overwritten. But started off somewhere, but we have learned a lesson. I think it's a good lesson, and we have fucking done 1 hour 45 minutes of coding, so it's good enough for today. My fucking brain needs to chill, and yeah, thank you guys. Have a good day. Bye bye.